This is higher homework 8. This is question 5, part B. Right, so what I have here is I've got a trig equation, and what I've got to do is I've got to solve this here. Again, I'm looking at the range. The range is in radians. Answer must be in radians at the end, between 0 and 2 pi included. Okay, so when I look at this here, what I can see is I've got everything's in cosine, okay, or cos. So I don't need to substitute anything in. What I'm going to do is I'm going to gather everything on the left-hand side, and hopefully I'll make up a trinomial. Okay, take the cosine over. It's positive on the right-hand side, so it'll be a minus cosine x, and the 1 will be a minus 1, and that equals 0. Okay, from there, what I'm going to do is I'm going to look at factorising that. Okay, to factorise, that'll be a cosine x there, and a 2 cosine x over this side here. Both of these multiply together to get 2 cosine squared x. I've got a 1 at this side here, okay, it is a minus 1, but the numbers that multiply together to get 1 would be 1 and 1. If that's a minus or a negative, one of them is going to be negative and one of them is going to be positive. That one there tells me there's a negative there, so the one that multiplies out the largest will become the negative and the other one's the positive. Okay, so from there what I'll do is I'm going to try and solve that. I'm going to take 2 cosine x plus 1 equals to 0, and on this side here I've got cosine x minus 1 equals 0. I'll just try and get cosine x on its own in both cases. So what I'll do here is I'll go for 2 cosine x, take the 1 over to the right hand side, becomes a minus 1, and cosine x is equal to minus a half. On this side here, on the right hand side, all I need to do is just get the cosine x on its own, and that's going to be equal to 1. Okay, so what I'm going to do is I'm going to look at solving this part here first, because I know that we can do that one quite simply, and I'll do that quite simply just by considering what the graph of cosine function is like. Okay, so the graph of a cosine function will start up here at 1, it'll come down here, go to minus 1, back up, and it'll finish back up there. So I know that this value here is 0, and it's 0 degrees or 0 radians. That'll be 1 there, minus 1, and where this finishes is going to be 2 pi or 360 if I'm working in degrees. Okay. Okay, and the points that I'm interested in, whereabouts is cosine x equal to 1? So it's 0. So from here I've got x equals 0, and also I've got x equals 2 pi. Okay. If I was doing this in degrees, I would still be stating x is equal to 0, because that's radians, but this is degrees, 0 degrees and 360 degrees. Okay, so that's me got it in radians and degrees. I would normally tackle this in radians. For this side here, what I'm going to do is I'm going to be looking in there, I'm looking at that negative sign, and what I want to do is to consider where that is on the cast table. So if I draw a cast table just here at the side, okay, there's a cast table, and what I've got is all sine tan cos. So all sine tan cos, I know that's a minus sign, so cosine is going to be negative. Okay, so cosine's positive here and positive there, so I'm looking at these two areas here to get my solutions. So that there is quadrant 2, that one there is quadrant 3, and that's where my solutions are going to come from. Right, so first of all I'm going to work out the acute angle. And the acute angle, the way I'm going to work that out is I'm going to be saying that cosine x is equal to a half. Okay, and yep, I've dropped the negative sign. Okay, so and what I'm going to do is I'm going to work out an angle that would be in the first quadrant. The way I'm going to do that is I'm going to be looking at the table of exact values, and from this table here what I'm going to do is I'm going to look and find where the cosine x is equal to a half, and that's along here, that's where it is. That's going to direct me to my solution, or my answer for the acute angle. That's going to be pi upon 3, or working in degrees, that would be 60 degrees. So that's what I'm going to use for this question here. Right then, so from there I'm going to say that x is equal to, and we said that was going to be pi upon 3. That's my acute angle. So the solutions I'm looking for are in quadrant 2 and quadrant 3. So let's go for a quadrant 2 solution. In quadrant 2, when I work that one out, I've got x is equal to, and the way to work this one out is, I know that's 0, this is pi as I go round. If I go back round a full turn, that will give me 2 pi, or 360 degrees. That will be 180 degrees. So to work out an angle that's in there, it would be pi, and I would subtract the acute angle that I worked out, and I'd find out what that equals to. So another way that we can work that out is if I'm working with a 3 in the denominator, I know that pi is just the same as 3 over 3 pi. So 3 over 3 pi minus pi will give me 2 pi upon 3. And that would be one of my solutions coming out there. For the quad 3 solution, okay, what I'm going to do is I'm going to be after pi, so it's going to add on. So it's going to be pi plus pi upon 3. And when I add that on, remember I'm just going to convert that to 3 over 3. That's going to give me 4 pi over 3. And what I've got there is I've got all my solutions. So in here, I'll just write my solutions. So what I can say is x is equal to, and I'm going to get my solutions from here first. That's a 0 up there, so that's 0. X is also equal to, let's go for them in order, so 2 pi over 3. I'll go for 4 pi over 3. And finally, my other solution is 2 pi. Good thing about writing the solutions is that so that you're showing that this is not a solution, the pi over 3. If I was doing it in degrees, so what I'd be looking at is I've worked out here that x is equal to pi upon 3, and from the table of exact values, I know that x is equal to 60 degrees. So my quad 2 solution is going to be just 180 minus 60, which equals 120 degrees. And my quad 3 solution is going to be 180 plus 60, which gives me 240 degrees. So what I've got here then is the solution. The solution will be, if I just look at it in degrees, first of all, we'll just gather these together. So there's 0, I've got 120, I've got 240, and I've got up here 360. So they're the 4 things that I'm actually interested in, but that's not what I'm going to finish off my answer as. What I'll finish my answer off as will be, I'll be changing them into radians. The way I'm going to change them to radians will be by multiplying them by pi over 180. So all I'm going to do is multiply them all by pi over 180. So here we go. X is equal to, so 0 times that, it's still going to be 0, it's going to be in radians. So 120 and 180 on the bottom, divide it by 60, would be 2 on the top, 3 on the bottom, and pi. I've got 240 on the top, divide that by 60, that will give me 4 on the top, divide that by 60 gives me 3, and 360 divided by 180 is 2 pi radians. And in here, that's also radians. Okay, let's have a look and see how we mark this question. So first of all, what I'm going to do is I'm going to get 1 mark for changing everything over onto the left hand side and creating the trinomial. I'm going to also take 1 mark just for factorising that out, making sure that the 0 is still in there as well right at the end. What I'll then get a mark for will be, I'll go for working this out here. Okay, that was that one there, so that's a 0 and the 2 pi, and then for getting 2 pi over 3 and getting 4 pi over 3 as the other. So that's 1, 2, 3, 4, 5 marks I'm going to take for that. If I look at it in degrees, the way I'm going to mark that will be, I'll get a mark for this part here. Okay, mark for this part here, just the same. I'm going to get a mark for getting these 2 answers here, the 0 and the 360. And I'll get a mark for getting these degrees here, the 120 and the 240. And then finally, a final mark for making sure that I state all of the answers in radians. So that's 1, 2, 3, 4, 5 marks as well. Okay, so this question here would be out of 5 marks.